A uniform bar 15-meter long is balanced on a pivot placed at its midpoint. A body of mass 55 kg sits on one arm of the bar at a 0.5 meter away from the pivot. What mass can be placed 2 meters away from the other end of the bar to keep the bar horizontally, that is, to make it to maintain equilibrium? So normally the question will not provide the diagram for you. You have to draw the diagram from the question. So a uniform bar 15 meters long. So the whole length of the bar from this end to this end is 15 meters. So is balanced on a pivot placed at its midpoint. So if it is 15 meters, half of 15 will be 7.5. So the pivot will be placed at distance of 7.5 meters. So that is the distance from the end of the bar to the point of the pivot. So next is a boy of mass 55 kg sits on one arm of the bar at a 0.5 meter away from the pivot. So the boy is 55 kg sitting at a 0.5 meter away from the pivot. So this is the pivot. From here to here is 5 meters. So what mass can be placed 2 meters away from the other end of the bar to keep it at equilibrium? So we want to calculate a bar, the mass M, that will be placed 2 meters from the other end. This is the other end. This is the end where the boy is sitting. This is the other end that we want to hang the second mass. So, and the mass is hanged at 2 meters away from the end. So with that, the diagram has been completed, and now we can calculate the mass using the principle of moment. So the M will exert a force which will go like this, that is the clockwise direction. So while the mass 55 kg will exert a force which will go in the anti-clockwise direction. So clockwise moment is equal to anti-clockwise moment according to principle of moment. So the clockwise moment here now will be mass times will be force times distance. That is force times distance of the force to the equilibrium. We are taking moment about the pivot. So this is the center. So from here to here, that is the distance of that force. So we say M times, so M times, what is the distance? Here is the distance, and that is 5.5, or that is yes, that is 5.5 meter. Because how did we get that 5.5? From here to here is 7.5. So if we remove these two, the remaining will be 5.5. So 5.5 is equal to, then mass 55, that is the anti-clockwise force, 55 times the distance from here to here, that is 5. That is 5. So we have M is equal to 55 times 5 all over 5.5. So 5.5 here is 1,
5.5 here is 10. So 10 times 5, 50. So we have M is equal to 50. So what's going to be the unit? That will be 50 kilogram, because this is in kilogram. The mass will also be in kilogram. So 50 kilogram. So